Hi everyone, this is Professor Oaks, and this video is about solving percent increase and decrease problems. So here is the first example. Jamal's monthly pay increased from $1,200 to $1,500. What was the percent increase in Jamal's salary? So what we are going to do is we're to find the percent increase. All right, so this is going to be the difference in the amounts. So in this case, it will be 1,500 minus 1,200. All right, so then that will be over the original. All right, the original amount. So here we go. I will try to make sure to write that a little bit more clearly so that you can see it. Original amount. So his original salary. So that means this was his original salary. And then this was his new salary. All right, so then that original amount would be 1,200, and then times 100%. All right, so we know that 1,500 minus 1,200 is, well, that is 300 over 1,200 times 100%. So what that means is that his increase in salary was $300 out of the $1,200 or $1,200 salary that he started with, right? And then times 100%. So let's see. So what we have is 300 divided by 1,200. That is 1 over 4. That reduces to 1 over 4 times 100%. So you can divide this numerator by, if you think about, by 300, and the denominator by 300, so that will be 1 over 4, right, times 100%. But 1/4 is the same as, all right, that will be 25 over 100. All right, so that would be, if you wanted to do this mentally, it would be 4 goes into 1 0 times, put down the decimal point. 4 goes into 10 2 times. 2 times 4, 8. And 10 minus 8 is 2. Then bring down another 0, and 4 goes into 25 times. So it's 25 hundredths. All right, so that will be 25 hundredths. So 25 hundredths times 100%. So 100 divided by 100 is 1. So we just have 25%. So this is a 25% increase in salary for Jamal. All right, so let's try again. Maury had 25 insects in his collection last year, and this year he has 47 insects. So this was the original number of insects in Maury's collection, and this was the new number of insects in Maury's collection. So what is the percent increase in the number of Maury's insects? So remember, the percent increase is going to be the difference in the number of insects, so 47 minus 25 over the original number of insects, 25, times 100%. So then 47 out of 25, that will be, what will that be? That will be 22 out of 25 times 100%. All right, and then if I do this mentally here, I have, well, what do I have? I have, well, here's another way to do this. All right, so 22 out of 25. If I multiply this numerator and denominator by 4, I have 88 out of 100. So this is 88 over 100 times 100%. And then the hundredths divide out. So then I see that this is 88%. All right, so there's another way to do this. And similarly, just to recall here, I could have done this up here. See how I had the 1/4? I could have just said times 25 times 25, and that's 25 over 100, all right? So I don't want you to think that I am just making things up. I'm just trying to make the math easier to do in my head, or some mental math here, all right? So, Mrs. Fang had 45 students in her class in the fall. So that would be the original number of students that Mrs. Fang had in her class, and then 54 students in her class in the spring. So that's the new number of students that she had in the spring. So then, what was the percent increase in the number of students in Mrs. Fang's class? So let me make sure this is focused for us here. All right, so now let's see. So we have the percent increase is going to be the difference, which is 54 minus 45 over the original number of students. So that's 45 times 100%. So we have 45 from 54 is 9. So 9 out of 45 times 100%. And then if I reduce 9 out of 45, I get 9 over 45, divide it by 9, divide by 9. That's 1 over 5. So 1 over 5 times 100%. But then if I take the 1 over 5 and I multiply this times 20, I get 20 over 100. So 20 over 100 times 100%. The hundreds divide out, and we have a 20% increase in number of students in Mrs. Fang's class. All right, let's try another one here. At a bakery, 100 cakes were sold in the first week. In its second week, 156 cakes were sold. So the original number of cakes that were sold in the first week was 100, and the new number of cakes sold in the second week were 156. So what is the percent increase in the number of cakes sold from the first week to the second week? Well, the percent increase is going to be, all right, so 156 minus 100 over 100, the original number of cakes, times 100%. So 156 minus 100 is 56 over 100 times 100. I could actually reduce the fraction 56 over 100 here, but you see that the 100s divide out, and I already know that this should be 56%. All right, so now let's try another one here. Braxton picked 500 apples from his orchard last week. This week he picked 671 apples. What is the percent increase in apples picked? So the 500 apples is the original number of apples that was picked by Braxton in his orchard last week. And then this week he had picked 671 apples. So that was the new number of apples picked this week. So if I want the percent increase in number of apples picked, so this will be percent increase. All right, so that will be, what will this be? This will be 671 minus 500 divided by 500. So that will be 171 over 500, all right, times, and this is again times 100%. So times 100%. And then what do you see here? Well, a couple of things. One of them is that all I really need to do then is say, well, all right, the 100 goes into 500 5 times. Right, so this is 171 over 5%, but I wouldn't actually just normally leave it like that, right? I would want to divide this. So 5 goes into 171. That will be 5 goes into 17 3 times. 3 times 5 is 15. So then 17 minus 15 is 2. Bring down the 1. So 5 goes into 21 4 times. 4 times 5 is 20. So 21 minus 20 is 1. Then I need a 0. So I'll bring down the 0. And 5 goes into 10 2 times. So it's 34.2%. So hopefully you enjoyed that example and seeing how I would go through the process of computing this mentally. So now that is it for the percent increase problems. So here are some percent decrease problems. So Kono used to drive 325 miles per week for work. So that's the old number of miles that he used to drive for work. So that's the original or the old number of miles that he used to drive for work. So he now drives 125 or 23.5 miles per week for work. So this is a new number of miles per week that Kono drives for work. So what is the percent decrease of the number of miles Kono drives per week for work? So the percent decrease will be the difference, right? The difference over the original amount times 100%. So here the difference was 325 minus 123.5 over 325 times 100%. So then we have 325 minus 123.5. So what is that going to be? That is 201.5 out of 325 times 100%. So now this might seem a little bit daunting, but let's go ahead and try to just do this long division here. So we have 325 goes into 201.5, and we need to make sure that we have the decimal point here. So 325 goes into essentially 2015. All right, how many times will that be? That will be 6. All right, so then my mouse is in the way, my keyboard is in the way. There's not much room here. All right, then 6 times 325 is 1,950. So then we have 2015 minus 1,950. That's 65. And then we have the 0. We'll bring down another 0 here. So 325 goes into 652 times. So 2 times 325 is 650. So that is a remainder of 0. So this really is a 0.62 times 100%, or multiplying by 100 means to move the decimal here 2 spaces to the right. So that is 62%. What a time to be alive. All right, so here's another great example. There were 125 people in a recreational sports league last year. So this was the original number of people in the sports league. So this year there are 95 people in the same league. So that's the new number of people this year. So what is the percent decrease in the number of people in the league? So here we go. We see that the amount definitely went down, so it is a decrease. So the percent decrease is going to be the difference, which is 125 minus 95 over the original number of people, 125 times 100%. So 125 minus 95, that will be 30. over 125 times 100%. So now, what do we have here? We could actually reduce this if we wanted to. I mean, it's up to you if you want to reduce this, but why not? Why don't we reduce this? So we have 30 over 125. So if I divide this by 5 and by 5, I have 6 over 25. And then if I multiply by 4 over 4, I get 24 over 100. So this is 24 over 100 times 100%. And the 100s divide out, so this is 24%. So there were, 24% fewer people in the league this year. So there's a 24% decrease. What a time to be alive. All right, so let's try another one here. Tatum had 160 stamps in her stamp collection, and she gave 36 stamps away. What is the percent decrease in Tatum's number of stamps? So this is her Tatum's original number of stamps, and this is Tatum's new number of stamps. So the percent decrease in the number of stamps that Tatum had was 160 minus 36 over 160 times 100%. This will be the percent decrease in the number of stamps that Tatum had. So 160 minus 36 will be 124 over 160 times 100%. All right, so this is really up to you how you want to go about doing this. But if you want to reduce this fraction, you definitely could if you feel like it would make this easier to do the division. Otherwise, you can just go for it. 160 goes into 124. All right, so then we'll put the decimal point. So this will be, let's see, what will this be here? So, yeah, so, well, okay, so here we go. So we have 160 goes into 1,240. All right, so that will be 7. So then 7 times 160 will be 1,120. And then we do the subtraction, all right? So now this will be 120. And then we put another 0 here and bring it down. So 1,200 divided by 160 is 7. So then 7 times 160 is still 1,120, and so I do that subtraction, and I'm left with, it should be, what is that, 80, and then I bring down another 0. 160 goes into 805 times, so 5 times 160 is 800, so that difference is 0. So this is 0.775 times 100. That will be 77.5%. So now what that is saying is that if you think about it, all right, if Tatum gave 36 stamps away, this actually is how many stamps that she has left. All right, so 160 minus 36 means that she had 124, so 160 minus 36 equals 124 stamps left. All right, so what that means is that Tatum really started with 160 stamps and had a new amount of 124 stamps. So another way to solve this problem would be how we did it, but then we would just take 100% minus the 77.5%, and then we have 22.50% is the decrease in Tatum's number of stamps. All right, so let's try another example here. Summer scored a 100 on her first quiz, and so that is her original score on her first quiz, and she scored 83 on her second quiz. So that would be her new score on her second quiz. So what was the percent decrease in Summer's quiz scores? All right, so the percent decrease is going to be, all right, so that will be 100 minus 83 over 100 times 100%. So that's 17 over 100 times 100%. I divide out the hundreds, so I'm left with 17%. So there was a 17% decrease in Summer's quiz scores. What a time to be alive. All right, here is our last example here. Blaze lifted 245 pounds on Monday, and he lifted 220.5 pounds on Tuesday. What is the percent decrease in the number of pounds Blaze lifted? So his original number of pounds lifted on Monday was 245, and his new number of pounds lifted on Tuesday was 220.5. So the percent decrease in the number of pounds that Blaze lifted would be 245 minus 220.5 over 245 times 100%. So 245 minus 220.5 is 24.5 over 245 times 100%. And then there's a couple of ways that you could do this, but one of them, if I'm again just doing mental math, is 24.5 times 100 means to move the decimal 2 to the right. So then this will end up being 1, 2. So that will end up being 2,450 over what is that? 245, and then I can just pull out the common factor of 245 and get 10. All right, 10 over 1%, or just 10%. There we go. So what a time to be alive. I hope that you enjoyed this video on solving percent increase and decrease problems, and that you are already looking forward to the next video. Thank you and have a great day.